So, welcome everybody. In this presentation we're going to talk about lasers as lighting fixtures, as lighting effects, and lasers as integrated multimedia devices. So this is something that is not only about lasers, it's about much more. Let's start over. So, welcome everybody again. Multimedia, lasers, there's so many things that come together in our industry, much more. Over the past years there have been so many developments that bring together all the different technologies. Before I dive into the topic, I just want to introduce myself so you know who I am and who is talking to you. I'm the CMO of the Laserworld group. My name is Norbert Stangl. I'm in the industry for quite a while, and I'm also especially responsible for software development and controller development in our company group. So this is something that is very interesting because what we're doing with this controller development is bringing together different media, different trades in our industry and combining it to enhance multimedia experience, especially with the laser part. What we experienced in the past years in our industry, and this is something that is essential to know why this is so important to have the development with the multimedia integrations, is that the show laser light industry has consolidated, has changed a lot. A lot of smaller companies have vanished, have disappeared, so the whole perception in the market is different now. One-stop companies have transformed or they're specialized, and the whole industry diversified. So Laserworld, company I work for, grew to a group of companies with an extensive global network of partner and alliances. So it's all about network, international business, but it's not only in the line of lasers, it's much more. There is multimedia, there's projects that integrate video, that integrate pyrotechnics, that integrate all types of special effects and conventional lighting as well. And this needs to go together. And what we learned in the past years, and especially during the COVID time, is that everybody needs to have that network to be successful and to integrate projects in a way that they are modern and state-of-the-art. Now, if we talk about lasers, lasers are not just the products themselves. There's so much more around it, which is quite special because it's different to normal lighting, it's different to other trades, because it's a special effect, but it has so many aspects to it. We don't only have laser systems, which is the core part, but there is also a lot of services that go around lasers which are very specialized. So we have from the laser safety installations, we have dry hire trainings, we have different type of artists which are very specialized, and that all goes together. So having this means so many service companies, so many services around lasers require a lot of interfaces and not a lot of connectivity between different entities and different trades in our industry. So we're probably the biggest laser manufacturer worldwide, and what is important to us, and this is what has proven to be the most important part, is spending significant amount of resources on development. Especially during COVID time, we were able to really move forward to bring in a lot of development in terms of connectivity. And this is something that pays off now because it gives us a lot of opportunities to work with, especially video, with multimedia and different other trades. Lasers need to integrate with conventional lighting and multimedia much more nowadays. We need to find new compatibilities between the different trades, because if we have a system that is very closed, that has no connectivity, no interfaces with other software or hardware, we are pretty much stuck in what we're doing. And especially if we have customers that require certain artistry, certain kind of integrations, and we're not able to transform content, to connect content, and to actually output content to different devices, we are stuck in a certain funnel where we cannot leave. So what was most important in terms of developing new solutions for connectivity was breaking up that funnel and making things interconnectable between different media. Lasers need to become intelligent lighting fixtures and more. This is something that was essential when we planned the whole development process, because we understood that we need to understand our customers, our users, to be able to make the units, the products, the lasers in a way that they are connectable. Now, the challenge with lasers in general was that lasers work differently than normal lighting fixtures. Normal lighting fixtures usually were intelligent lighting devices. So what you have with a moving light is you have that moving light, you have intelligence inside that moving light. So the moving light has certain features that it can do. You have gobo, you have whatever color, you have all these features, and you have a mainboard that controls these features. And this is all the intelligence inside the device. You just have a stupid control signal that comes in and tells the device what to do. Now, with lasers, it used to be different, completely opposite actually. So what we had a super stupid device. There was no intelligence inside the device at all. And we needed to bring in all the intelligence from external. With this bulky 25-pin printer cable you see up there, it's like a really old type of connectivity, which was state-of-the-art like 30 years back, which was really good in those days. But nowadays, when everything goes digital, everything goes like interconnectable, we cannot have this kind of setup anymore. So in the past, we needed to bring in all the full control signal for the lasers from external, because there was no intelligence inside. Now, if we want to create compatibility between different devices, we need to break up this structure, because it doesn't work if the lasers have no intelligence, because we need to be able to communicate with other devices and trades. So the challenge was, how do we get intelligence inside the device and also do it in a way that we, on the one hand, maintain the features of a laser so it can be used as a laser, but also make it connectable with lighting, with video, and with other trades. So this is what was the initial idea when we tried to find a way to develop new mainboard solutions, new connectivity solutions. What we came up with was a new mainboard that we developed. It was the ShowNet mainboard. This is one solution that we developed. We have another one. And the ShowNet laser mainboard is now a central component in most of our laser systems and many other laser systems as well. So you have that built in, and you have a lot of intelligence now inside the laser. So the laser becomes an intelligent fixture, and you can bring in content into the laser, but you can also feed it in real time. This is something that makes lasers different, or makes lasers similar on the one hand to video and on the other hand to lighting, because we can feed content in a live way, but we can also trigger content that is stored inside, which is quite cool, because that helps a lot in different types of installations, different types of projects, if we just use the lasers in a different way. Lasers became intelligent laser systems, not like stupid boxes. Now we have intelligence, and with this intelligence we can do much more than just having laser software and drawing like comic style animations and have them output. We can do much, much more. What we can do is, first of all, integrate lasers with video control. Just recently, we had a new API for that Mainboard. We published that API and worked together with different multimedia companies to make the integration possible with popular video control software. Now, video is something you cannot go without at any event, because you need video everywhere. Video is everywhere, and there's a lot of people that know how to control video. Much more people than who know how to control lasers. So what we have here is integration with video control, for example, with MadMapper, MadLaser, which is quite a popular software, and also with Touch Designer, just recently with the latest update. And others are upcoming. Millimin, for example, also integrated it, which is a Mac-based solution. So there's different kinds of multimedia software products and multimedia softwares in general that integrate lasers as native output devices. But we also have the laser integration with lighting. There is even more people that are familiar with lighting control, with that classic lighting control that we have with whatever GrandMA console, Avolites console, Chamsys consoles, whatever kind of console you use. It uses all a similar principle, triggering existing content, but it also has the advantage that you can use large-scale setups. You can scale it to a huge extent. And now as lasers became so affordable nowadays, this is something that is essential. We need to be able to scale setups easily. But this is not possible with normal laser software anymore. We need to think about new methods. We have integration with multimedia. So it's not only about lighting. It's also about integration with sound. It's about integration with video, but also special effects, pyrotechnics, whatever. There's so many different media that come together that need to work together with lasers to make an immersive experience with multimedia productions. We have even more, because lasers become popular for building automation and advertising situations as well. So we have different types of industries that come up to lasers because we now offer connectivity options for their needs. So it's all about connectivity and interoperability to make that a multimedia experience, a total experience. I just brought a chart. It's a bit kind of irritating probably due to all these arrows, but they show the possibilities you get if you have an intelligent mainboard that can serve different purposes. I'm not sure how familiar each of you is with lasers, but in the past it was not possible to just have connectivity that easily. You needed to have a lot of external hardware devices and, you know, put in different kind of converters to get things going. Now, for example, on the left-hand side, you see the content part. So we can create content with show controller software, which is a classical laser software, show editor as well. We can use MadLaser. There we can input video to create laser output. So video people can just use their video content, how they know to create content, to output to laser. With Touch Designer, we have the option to make huge, complex, multimedia immersive projects. If you come down to our exhibition booth in hall, go up, hall 12.1 E50, you can see such an installation. We put in there a combination of Resolume video with Touch Designer and with laser interacting with a video. So this is a complete new way of thinking lasers, connecting lasers with other media. We have Millimin, we have ILD render, and we have other softwares that just in development using the API to being able to directly output to the lasers. This means they just connect the computer with a network cable to the laser, and they get going. There is nothing in between, no additional software, no additional licenses. It's just as open as it's possible, so everybody can make these connections and use lasers to the best. So this is the API. That means we can have software control. But there is more, because we have built-in intelligence as well. So what we have built in is we can store content. We can create geometric corrections inside the laser and store it inside the laser. This is important because if you have huge setups, you don't want to have software control in between, but you want to have each laser adapted to the very situation that you have in the multimedia setup. That's why you need to be able to modify the geometric correction inside the laser. So this is built in as well. And then there is something that is super important for lighting designers. Because lighting designers have a certain way, and lighting operators have a certain way of controlling lights. And it definitely makes sense to do it that way, because it is as they use lighting fixtures, as they use their moving lights, as they use any other type of lighting fixture. Now, lasers are slightly different. So the challenge was to make the whole intelligence on the DMX and ArtNet side in a way that it matches with the requirements of lighting designers. Now we have another challenge when it comes to lasers, which is an important challenge actually, which is laser safety. So we also needed to consider laser safety when it came to different controls. Now the thing is, if you have DMX and ArtNet, it's not a safe protocol to work with. So if you have a glitch on your DMX signal, the beam can go anywhere. And this is something you cannot have with lasers. It doesn't matter if you have a moving light that just, turns in the opposite direction. That's just annoying, but it's not dangerous. With lasers, it can be dangerous. So for us, it was essential to bring in a safety feature that you can control with DMX only. You don't need any additional software, because lighting designers that work with their console, they don't want to have an additional computer to deal with the lasers, because that's super annoying. So what we made here is we brought in a DMX profile that is not only one layer, but it's a double layer profile. You normally don't have that with normal lighting fixtures because you don't need that. But with lasers, we have to deal with that specialty. So it works like this. You have two certain DMX channels. And if you put these channels to two different values, it's not full on obviously, but it's two specific values, the main board of the laser detects that and switches to a setup mode, which means that everything you do afterwards, like making a zone, projection zone, making a safe reduction zone where there's reduced intensity, you set that, and then you put these two channels to two other values, and it stores these settings you just made back into the main board. So all these settings are saved inside the laser. Now, if you later on hit full on your console, everything will stay inside that zone you just set. So this is something that is super important. It's very uncommon because you don't have that kind of feature for normal lighting fixtures. But for lasers, definitely makes sense. And it's super convenient to use. Imagine you not only have one laser, but you have 100 lasers on stage. You can simply select all of them. And then set the zone, save it back, and everything is above head. For example, all the lasers at once. No software, just DMX. Or ArtNet, of course. There is another option that we developed. It's more for installations. This is not too much about versatility. It's more about compatibility and signal reliability. Because depending on the project, you probably have different requirements. And as we're talking about multimedia, it means many media. So each type of media may have different requirements in terms of signal stability, in terms of features, in terms of different kind of aspects. Now, we still have this content creation situation. You see there is more different types of softwares that can create content with this type of transmission. And then we have different options. Now, with this concept, the signal transmission is most important. So we have a different mainboard. This is especially something for the top-end products. We have a different mainboard built in there, and it's all about stability for signal transmission. So with this concept, we have the option to use AVB, which some of you may know from video and sound. It's AVB TSN. Or we have a new transmission situation that comes from ILDA, which is an International Laser Display Association. They made a new digital network standard. We can use this, and we can also use Dante, which some of you, especially the guys from sound, know very well. We can also use Dante as transmission for laser control signals nowadays, which is, as you can see, very handy if you already have an infrastructure that is in place for your sound, for your video, because you can hook up to existing infrastructure and work with it as you would expect it with sound or with video, depending on what type of control you use. So this gives you a lot of additional opportunities to interconnect between different media with different controls. And then we have the output. So from content creation, signal transmission, we go to the output, and the output happens from the laser. The laser does the output, but it's an intelligent output because it converts the signal in a way that the output matches what you require, because you can calibrate the laser in a way that it matches these requirements. So this is an additional mainboard we have. So for example, with these top-end products, the Picos, for example, they have two mainboards inside. So you have all the connectivity options. You have a Shonet mainboard, and you also have a laser animation Solinger mainboard that controls different kind of transmission signals. So there is a lot of things going on. Probably in the future we merge these, but at the moment it doesn't make sense for several reasons. But maybe these things merge in the future, so we have a lot of connectivity and compatibility options. And of course, we can use timecode or other trigger signals to then trigger the content, which is something that is essential for multimedia productions. Because it's not only about live streaming content, it's also about recording content and then playing it back at the correct time. Now, I talked about all the different trades that we have, multimedia, we have the video, we have lighting, we have pyrotechnics and sound. But if we come back to lasers a bit, we also need to consider what type of control we would require for which type of show. Because obviously, not everything makes sense for every type of show production. Because obviously, lighting designer says, okay, I always use DMX. And the laser guy says, oh, I always use my laser software. And the video guy says, I always use my video software. But this is not what compatibility is about. Compatibility is about that you can use the correct tool for the correct application. Now, thinking of this requires understanding how lasers work and how you use lasers. So, for example, you can have a front projection. Front projection means that the laser faces towards a surface. Now, having this situation, you usually would not go with DMX, because DMX is not the best option to go for if it comes to graphics, because you cannot control the fine lines, the fine laser output. So that you wouldn't do that with DMX, but it's perfect for video. For example, video, you have Map Mapper, Touch Designer. That software you go for, classic laser software, that is what you would use for this. Then we have rear projections. It's the same thing, just the other way around. So this is also something that you wouldn't do with DMX. But there is other things, other applications like atmospheric projections, where the viewing perspective of the spectator is with the laser. This is something you have with huge outdoor installations where there's beams shooting across, and this is what you find there. Now, the most common application you find with lasers is obviously the beam show. That can be with or without audience scanning. And that means that the laser faces the direction of the spectators. This is where lasers actually are best visible. So you would normally try to have that kind of perspective if you want to have visibility of beams. And this is something where all the different types of controls come into play. So that gives you most versatility. DMX and ArtNet controlling lasers becomes very convenient and safe with a ShowNet mainboard, for example. This is what we just saw, and we need to rethink how lasers are used when it comes to mass controlling lasers. I initially said that lasers became much more affordable nowadays. And this is something that is important to consider when it comes to controls. In the past, lasers were super expensive. Like 30 years back, 100,000, 200,000 euros for a 10-watt laser, or no, it wasn't even available, like 5-watt laser, extremely expensive, and it was really difficult to handle. Nowadays, we have super affordable, low-priced lasers, and our show productions require them to be controlled all together. So not only one laser, two laser. No, you find stages where you have 50 laser, 100 laser, even 200 lasers on stage. And they need to be controlled. And they need to be controlled efficiently, because obviously you can do it with all types of controls. But it's super, super complicated to do a proper live production if you use like classic laser software with even 20 lasers. It's difficult. Now, lasers and the effect of lasers has changed with the lasers becoming less expensive. Because in the past, lasers used to be a solitary effect. You had like one laser or three lasers, and we made laser show. So there was lasers, music playing, and people were sitting there and watching the laser show, they applauding afterwards, and that was the laser show. Nowadays, lasers integrate. They integrate with multimedia. They integrate with video, with other lighting fixtures. And they also are mass effects. So what you have is not only one laser, you have the 20 lasers. Now controlling them together makes total sense to use DMX or ArtNet, because you can use effects generators to make nice waves, to make color transitions and all that. If you want to see that, by the way, come up to hall 12.1 E50, just in the center of the hall, and we have 58 beams that move together, but they are all controlled only with DMX, and you can see how easy it is to make effects like that. You couldn't do that with a lighting with a laser software. It would take ages to program, but with a lighting desk, it's a matter of minutes to just get the effects done. So the lasers in that context become a unity of devices. So the effect is all the lasers together, and this is how it looks like. So what you can see is it's not only the laser beam moving, we also have like a 5-dimensional effect. We have colors, we have shapes that transform, and we can control all that with a lighting desk. And it's super simple. Everybody can do that with a lighting desk. If you just have basic skills in lighting control, you can do that with lasers. If you have the right mainboard, the right intelligence inside the laser. So this basically shows that lasers become lighting fixtures because it's so easy and convenient to control them nowadays. But, and this is important, you always need to consider the safety aspect as well. Every lighting designer can control lasers with integrated ShowNet mainboard without the need of any additional computer. You can use a computer, of course, you get some more features, but you don't need to. But if you do, it's diversified much more than it used to be in the past. So we have an API for direct connectivity, as I said. And with this API, different softwares can control and access the main board. These are the currently supported softwares. There's even more. There's Millimin already. And there is more upcoming. Popular software that probably some of you already use will probably have laser support in the future. Very simple. Just connect laser and get going, just with a network cable. And this is what the future will be. Easy connectivity and easy interoperability. Let me show you some different examples of laser show applications and what the story behind is and how we integrated that, how multimedia was integrated in these kind of shows. Obviously, in the left upper corner, we have lasers emphasizing video. So it's a combination of video and laser. And this has been done with laser control software, classic laser control software in combination with video synchronized with timecode. On the upper right, you see an application where there is a hydro shield, which is like a shield of water, a water spray that comes up from the bottom. You can have it in a lake and then it sprays up and then you can project towards it. And you also see we have a combination of video and laser. Because laser is a great effect for emphasizing. It's not good for filling in areas. That's not good. We cannot make filled areas, but we can really emphasize things a lot. And you see that in the upper right picture. On the lower left picture, you see writing on water. This is something you cannot do with conventional lighting fixtures. This is something that you need a lot of energy for, and this is with lasers. Now, this could be done with previously storing the content into the laser and then triggering it, of course, because it's not that complex. But you can also use lighting software, laser software to do effects like that. On the lower right, you see something that is very special. That is a mapping situation where there's a combination of conventional lighting, illuminating the church, lasers doing a mapping towards the church, and lasers doing a beam show that was controlled with DMX. So it's a combination of different controls together. So different media, different controls come together in one project. You can synchronize that with timecode, of course, but there's different options to make things play together. Of course, there's classic laser software as well, like Show Editor that you get for free to just get going a bit, make content. So that, for example, is a free software where you can create content and store it into your laser. So if you buy a laser that has this mainboard, you can use that software to create content, load it to the mainboard, and then use your lighting desk to trigger it. So you don't have additional costs for software. You don't have to buy additional software. You can use the software because it's free to use with these kind of boards, and it's a standardized file format as well. It's the ILDA file format that you can also use with other lasers, with other kind of playback devices. So there is also compatibility there on the file format level as well. So this is a free version you can use. So even if you don't want to buy laser software because you're just a lighting guy and just want to use lasers as lighting fixture, you don't need to buy software because it's there and you can make like your gobos, which is basically what you do with it, like logos, texts, animations, yourself. There is a more professional software, which is Show Controller. That's the professional software for multimedia production. So what you can do with it is you can put video on the timeline. You have timeline. You can trigger that with timecode. You can also send timecode. You can put multimedia events on the timecode, and you can connect that with other multimedia software, with your video software, with your pyro software, with your water show controllers. Everything is made as compatible as possible to make shows more immersive, more enhanced for really modern multimedia productions. Okay, let's have a look at what is possible This was at Prolight Sound here. Basically, it was in the Festhalle when the Festhalle was still in place with the PRG stage show. And this is a show where lasers have been used in combination with all the different media. You see that? The lasers moving behind the singer. It's a multitude of lasers and they all have been controlled with DMX. This is a multimedia show in the Bird's Nest in Beijing, where lasers have also been used for emphasizing, but also for graphics. And it's integrated to the rest of the production with a certain type of intelligence. This was the previous intelligence we had, but it's moved on from that and evolved further. For these kind of productions with bringing into all the media together, you require a lot of connectivity, a lot of interfaces to connect between different media. And with lasers, it used to be really difficult in the past. Now, you don't need a specialist anymore. You can handle it yourself. And that makes it much easier, especially also for designers, to get going with lasers and to trust in lasers as an additional effect for their multimedia production. So, what you see here, especially here, you see the movement. And all this is a classic DMX control. Because what we see much more at festivals, as we see all these many lasers at festivals nowadays, that lighting designers start to use lasers and control them in connectivity with their lighting setup. Those of you who use the advanced controls, the latest bigger arena controls, like from Avolites, Camsys, MA, the big controllers, they offer connectivity solutions with other media. So lighting designers control much more than their light. They control the whole experience in the hall. And to be able to do that, we need to have the connectivity with lasers as well. And that needs to be easy, that needs to be safe, and that needs to be something that everybody can handle with just their console. No additional hardware required, no additional software, no additional licenses. So, this is the end of my presentation. Thank you very much, everybody, for attending. If you have any questions, just feel free to ask me. If you want to know anything, if you want to learn a bit more about it, you can visit me in Hall 12.1, stand E50. Very welcome to come by and ask me questions. But if you want to ask a question now, feel free to do so. Any questions? No? Okay. Thank you very much. It was a lot of input. Thank you very much for coming. Probably I see one or the other of you at our stand in Hall 12.1 later. And those of you who are here still on Thursday, I want to invite you to our stand party. We're going to have a stand party as well, so starting at about 5:30. Come by at our booth. We'll have drinks. Yeah, very warm welcome to everybody. Thank you very much.